So now we will move to the vector autoregressive models. Mike. Vector autoregressive models. What these models are, basically, suppose you have, you will often see the relationship which are two-sided in economics. For example, if I discuss the relationship between income and education, what do you think? Higher income leads to higher education, or higher education leads to higher income? What is your opinion about this? It's bidirectional relationship. The higher education leads to higher income, and higher income leads to more education. Similarly, there is discussion about exports and growth. Sometimes export is leading and growth is following, sometimes growth is leading and export is following. But anyhow, they may have two-sided relationship, and there are so many other situations in which you may have two-sided relationship. Even in simple consumption income analysis, you may have two-sided relationship. How? You know that your simple consumption function is C is equal to alpha plus beta y, and y is your national GDP. So what is y? Y is equal to C plus x plus I plus G. Is it so? Net exports and investment and government spending. So what happens? The consumption is depending on income, and income is depending on consumption. These are two kind of relationship. Actually, when this kind of situation arises, this is called endogeneity. And it is usually said that when you have endogenous regressors, then your regression shall produce biased results, right? But that is the thing when you have endogeneity, but you don't understand that there is endogeneity, then you will get biased result. But if you know that there might be endogeneity, you can make it a part of model. You can model the characteristics of endogeneity so that you can get better results, right? So one way of modeling endogeneity is the autoregressive function. For example, I have two variables x and y. I am writing x as a function of lag value of x and lag value of y. And similarly, you may have this thing a21 x t minus 1 plus a22 x t minus 2 plus, as usual, you should have epsilon 1t and epsilon 2t, right? Now this model can be written into matrix format. If I write the thing like this, xt yt is equal to a11 a12 a21 a22 into xt minus 1 and yt minus 1 plus epsilon 1t and epsilon 2t, right? Now I can write this as symbol xt is equal to, this is matrix A into xt minus 1 plus epsilon t. Now look at this equation. This is looking like autoregressive model, but the stochastic variable in this is not a univariate variable, rather it is a vector. This is also autoregressive model, but the autoregression is defined on a vector, right? So that's why this is called vector autoregressive. So you already have constructed the model in such a way that you are already modeling x as a function of x and y, both leg values of x and y, and then y as a function of x and y both. So the endogeneity is made a part of the model. This is called vector autoregressive model, and you can label this VAR model as VAR1 because it is having only one legs. Sometime you may have more than one leg, and in that case you will have, for example, there is another matrix here, and plus you have xt minus 2. It will become, it will be basically like this: xt is equal to a1 xt minus 1 plus a2 xt minus 2 plus epsilon t. This will become the VAR2 model, and so on. You can extend to any number of legs, right? Now sometimes you may need to incorporate the trend and intercept in this model, and that's also possible. For example, suppose the model is like this, plus here is intercept alpha 1 alpha 2, plus you have beta 1 t plus beta 2 t, and then you have epsilon at the end. Right? If you want to write this model in the matrix format, what will happen? This is already there, so you have to add so plus what I will do, I will write here alpha 1 alpha 2 and beta 1 beta 2, and the multiples are 1 and t, plus epsilon 1 and epsilon 2 इनके साथ भी t है, right? This is also VAR model with added deterministic term, with addition of the intercept and linear trend. Now you can estimate this kind of models, and these kind of models are having some beautiful characteristics. For example, you can make forecast out of these models without, this is also just like ARDL, this is also a theoretic model. There is no direct theoretical interpretation of the coefficients that you will achieve from this model. Sometimes you may restrict the models to come to some model which is consistent with theory, but in general this is a theoretic model. You don't need to worry about the theory. But what happens, this a theoretic model is sometimes providing you better forecasts than many of the theoretical models. Why this is providing better forecast? Just like ARDL model we have seen yesterday, the ARDL model is a more general format, and there are many theoretical models which can be driven out of the ARDL model. So the general format is having better predicting performance than all of the subsets. And in a similar way, this vector autoregressive model is also capable of providing you good forecasts without worrying about what the theory is behind. So if your objective is only making forecasts, then you can just estimate the VAR model and you can make forecasts. And I will tell you how to estimate these VAR models. What I am saying, there is no direct interpretation of the coefficients, or rather you can make only forecasts. If you want to do the theoretical discussion, then you have to reduce this to some kind of theoretical models and then you can discuss, right? Otherwise this is only useful for making forecast. Okay, so let's see what are the assumptions of this model. The assumption is epsilon 1t expected of epsilon it, I is equal to 1 2 दोनों हो सकते हैं, it is equal to 0 and variance of epsilon it is equal to sigma square I and the covariance of epsilon it and it minus 1 t minus j. J could be any number. This is equal to 0. J may be 1 2 3, right? This is basically a generalization of autoregressive model. The ARDL model is